Imagine, if you will, a hedgehog with a peculiar ability. This hedgehog, unlike its peers, has the unique power to predict the future. But sometimes its predictions go awry. It's off by a few degrees or a couple of days. This, dear listener, is where our story begins, and it's a tale that will take us deep into the world of model debugging and residual analysis in machine learning. In the realm of machine learning, models are akin to our prophetic hedgehog. They predict outcomes based on data they've been trained on. But like our hedgehog, sometimes these models get it wrong. The difference between the predicted outcome and the actual result is what we call a residual. Residual analysis, therefore, is the process of examining these differences, or residuals. It's like investigating why our hedgehog thought it would rain on Tuesday, but it ended up being sunny. By studying the residuals, we can uncover patterns that our model may have missed and improve its accuracy for future predictions. Now, how does one carry out a residual analysis? Picture a simple scatter plot with residuals on the vertical axis and predicted values on the horizontal axis. If the dots are randomly scattered with no discernible pattern, it's a sign of a well-behaved model. But if the dots form a pattern, then the model has missed something, just like our hedgehog missing the sunny Tuesday. On to model debugging. Think of this as the process of understanding why the hedgehog's predictions are off. It involves looking at the model's inner workings to find out where things went wrong. This could mean examining the data the model was trained on, checking if the right features were used, or ensuring the model was correctly specified. There are various techniques to debug a model. One common method is to use a validation set, a subset of the training data that the model hasn't seen before. If the model performs poorly on this set, it could indicate overfitting, where the model has become too complex and is essentially memorizing the training data rather than learning from it. Another technique is to use visualization tools to inspect the model's behavior. This could be a plot showing how the model's performance changes with different parameters, or a chart highlighting the features the model considers most important. To sum up, model debugging and residual analysis are key aspects of building effective machine learning models. Residual analysis helps identify patterns that the model may have missed, while model debugging involves understanding why the model is making incorrect predictions and taking steps to correct it. Just like our hedgehog, machine learning models aren't perfect and can make mistakes. But with careful debugging and residual analysis, we can guide them towards better and more accurate predictions. After all, even a hedgehog can learn to predict a sunny Tuesday.